Hi guys, welcome to Typical channel. For this video, I'm going to show you how do I create the train and test model for our each gender data sets. And let's get started. Alright guys, thanks for watching my video and welcome back to my videos. So as for last video, we have already created our instant model function, and for this video, we're going to be fully focused on creating the train models and also test model functions. So let's start with our train model function first. Okay, first of all, I will create a train model functions, and is expecting the model itself. And our data loader, I will name it as dataset for now, or I will say dataset loader. And then our options, which is an argument parser that are several variables that we're gonna use as dynamic parameters for when we are running the trainings. All right. So in the model that we pass in, actually if you refer back to our instant model functions, so there will be a three variables will be returned from these particular functions. So we are expecting three variables here. So yeah, let's destructure it. So it will be our model, optimizer, and our criterions. So it will be the structure from our models, parameters. Then we're gonna for epoch in the range of options dot epochs, which we're gonna pass in from argument parser later on. And then we're gonna have another for loop that I will say is the phase in. We have two types of phase here. When every time we finish our training, we're expecting a validation phase as well. So I'm gonna say is that we're gonna look through every training. After every training, then I will go for validations in each epochs. So there will be a parameter setting here that to identify whether it's trained or a validations, because this is a variable gonna use for our model trainings in PyTorch later to indicate whether it's in training phase or in the validation phase. So I'll say true if phase equal to trained, else is false. Then I'm just gonna say that model dot train is trained. Then I'm gonna import another packages from Python which call tqdm import tqdm. So I'm just gonna say the target iterator is equal to tqdm, that we're gonna pass our data set loader inside. That I'm gonna start to loop it for index and data in enumerate target iter. Then we're gonna destructure a little bit. Image and our label will be equal to data, right? So our image dot to image dot to options dot device, right? Then we have three different label. I will say ETH label will be equal to label that ethnicity dot to device, option dot device. Then our gender label it will be label general dot to options dot device, and then we want to make sure it is dot to touch dot float 32. H label, it will be H dot to options dot device, and then dot to touch dot float 32. So for our general and also H label, because we are only expecting one output and it will be in float type, so we need to make sure our label will be in float type as well, because when we are doing the loss functions, so the direct comparison and also calculation will be performed in float type instead of integer, because we are not doing a multi-class classification, but instead only doing binary, which is only one node output, and also the regression also one node output. Alright, so we want to make sure our optimizer have 0 gradient. Then we're gonna start our forward parse. Will be our model, and then pass in our image. Then if you refer back to our custom H models, every time a forward pass completed, we'll get a return of mapping, which is ethnicity, gender, and age. Alright, so we need to destructure here. So I'll say ethnicity out is equal to our forward parse, which is ethnicity, our gender out, gender, age out. And then we want to make sure we squeeze it into one dimensions. Once we get our forward pass, so we want to do the loss functions now. So I will say ETH loss is equal to criterions. Oops. That need to compare with our ETH out and also ETH label. Alright, so next will be our gender loss, our criterions, and then it will be gender, our gender out, and then our gender label. H loss, criterions, H, then our H out, and then H label. Then our total loss will be ETH loss plus our gender loss and plus with our H loss as well. Right, we get all our loss. Then we just want to make sure if phase is equal to train, right? We only want to do a backward propagation when during training. We don't want to do it on our validations, right? When it is train phase, so we only call the total loss dot backward. And our optimizer dot step. All right. Then in each phase, I would say is phase loss. Then we start with 0. We want to track our phase ethnicity loss as well. And then our phase age loss and phase gender loss. Alright, then I will see our phase ethnicity accuracy is a list when I append it. And then our gender accuracy, right? So in each phase, where be it a train or be it a validations, so we want to keep track of all this stuff. So our phase loss will be plus equal to total loss dot item, right? So next will be our phase ethnicity loss, ETH loss dot item, then our phase gender loss, then our phase gender accuracy dot append our gender label that are equal to our gender output dot we want to sum it up and all the item divide by our gender label dot size 0. Alright, so then our phase ETH accuracy will do the same thing, right? Which is ETH underscore label, which are equal to our ETH underscore output, and then we're gonna just sum it up dot item, and then we're gonna divide to ETH label dot size 0. Alright, so until here we get our for each phase, right? We able to phase loss. Oh, we are missing out our. Okay, so there are typo here, loss. Alright, so until here, we in each phase, let's say it's a train, right? So we will go for the training. Alright, so there's a missing part here. We want to make sure our data loader are getting the correct phase, right? Let's say when we come to train phase, so the data loader will point to our phase, right? So we should refer to here, right? There will be a train iterator, the validation iterator, right? So when we get, let's say it's in the train phase, right? So we want to make sure now it's a training phase, and then we tell our model, now please go into a train mode. Then we instant several variable for tracking. for our loss and also for our accuracy. Then we want to make sure we get the correct data loader. Let's say it's a train, it will be a train data loader. Validation, it will be the validation loader. And we pass it into the TQDM. Then we start to enumerate it, and then we destructure our image and labels. Then we want to pass everything, our image also, to our device, be it a CPU or a GPU, right? Then we make sure our H and gender is in float32 type. Then we start with our model. Then we start with our optimizer, right? We make sure it's in zero gradient. Then we start for our forward pass. Then we get our output. And then we start to calculate our loss functions. Then we get our total loss because we have three different loss functions here. We want to get a total loss. Then we want to track if it's in train phase, we only perform the backward propagation. And after we perform the backward propagation, we want the optimizer to step forwards, right? So if it's in validation phase, so we're not gonna do these two things. And then we want to make sure we collect the total loss for this particular epochs and also the phase, right? So, all right, then we want to make sure we print out in every forward pass. So I'm just gonna say my target iter dot set the descriptions. So the description's gonna be start with our epoch out of our epochs, then with our total loss, and then our ethnicity loss, then our gender loss, age loss, then our gender accuracy, then our ethnicity accuracy, then we want the dot format. Okay, the first one will be our epoch, and then it's got our total epochs options dot epochs, right? The next one will be our phase loss, which is our total loss. Oh, sorry. The next one will be our total loss dot items, our ETH loss dot item, gender loss dot item, our age loss dot item, our face gender accuracy, last item, which is the latest one, and face ETH accuracy, last item. Right, so you're gonna say target ether dot refresh. Alright, so at the end of our phase, I'm gonna say print phase train organization completed with, so I'm just gonna say epoch at phase completed with total loss total ethnicity loss total gender loss total age loss ethnicity accuracy dot to f percent, right? So gender accuracy percent dot from it epoch options dot epochs at face, which is our face, then our total loss our face loss face ETH loss face gender loss face age loss. Then we want to get our face accuracy ETH accuracy divided by the length. Oh, sorry. Let's put it in a new line. We want to get the sum then the next one also will be the sum of our face gender accuracy and then divide by the length of our face gender accuracy. Okay, let's make sure one more time. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Correct. So let's before that print a empty new line. Alright, so if face is equal to validations, so next we want to do is to track when should we save our models, whether be it every epochs or with some conditions here. So at every end of validation, we want to print an empty line first, right? If it's a validations to indicate the end of each epoch. So we just print something, right? Then the empty line again. Then we want to create a tracking loss. I would say the best loss, right? It will be as much as possible, right? So we want to make it as big as possible so that in each loss, if any loss is lesser than this amount, we will replace this amount and we will perform a saving of our models. If phase loss, right, is less than our best loss, then what we want to do is calling torch dot save our model. That we're gonna provide a directory for saving our model. So I'm just gonna say options dot save directory, which is a directory that we're gonna pass in the later on session with argument parser, and then join with the name of the model. So I will say this one will be hgender best.pth. Alright, so our best loss should replace with phase loss, which is the best for now. Alright, so at the end of our model training, we want to return the model.static. Alright, so we have completed our train model function. So the next one, I'm just gonna have a quick one to create our test model functions. It's for testing our model purpose when we are completing all the training. So it's expecting a model and the data set itself and the criterion and then our options, right? So let's destructure our CRIT, ETH, CRIT, gender, CRIT, H, which we're gonna destructure it from our criterion. So our criterions will be first ethnicity, criterion, second one will be our gender, and the last one will be criterion H. Then let's create our total loss, total ETH loss, total gender loss, total H loss, then our ethnicity accuracy, gender accuracy. Right, then we start with torch dot no gradient because we just want to do a pure inference. We are not doing any training, so we just call this with torch dot no grad. Right, so as usual, we say our iterator will be our data set. At here I'm just gonna say test, and you will be wrapping with tqdm for index and data in enumerate. Our target iterator, then our image and label need to be disrupt from our data. Then our image is equal to image dot to options dot device eth label ethnicity dot to device options dot to device gender label gender dot to option dot device dot to torch dot float 32. Alright, so the last label will be h label h dot to option dot device dot to touch dot float 32. Then let's have our forward passing, which gonna use our model that pass in our image eth underscore loss our criterion of eth our forward pass ethnicity compare with our eth label gender loss, the criterions of gender for pass gender label, then our age loss criterions of age for pass age underscore label. Alright, then we need to make sure we squeeze it. Same for the age, SQUEEZ. Right, then our total loss will be equal to ETH loss plus gender loss plus age loss. So we need some loss. Alright, so our total loss need to sum up with our sum loss dot item total ETH loss plus equal to ETH loss dot item total gender loss plus equal to gender loss dot item, total age loss plus equal to age loss dot item. Alright, so our ETH accuracy dot append ETH label that equal to for parse ethnicity dot sum dot item. Divide by ETH label dot size 0. Alright, gender accuracy dot append gender label our for parse gender dot sum dot item gender label dot size 0. So at the end of finishing all the inference, so we just gonna print out right. Then we just want to make sure everything applied to F. For a nice view. Same as here. Don't forget our percent here. Alright, so we have completed our train model functions and also our test model function. In the next videos, I'm gonna show you guys how do I create the argument parcel so that we can pass in several parameters such as the model safe directory, where is the data sets, and etc. Right, and then I'm gonna instance our train model function and also test model functions, and we will start the training in the next videos. So until here, thank you guys for watching, and I will see you in the next video. Bye bye.